Now this time we're going to go the other direction. Notice my equation is starting with r's. I want to change it into x's and y's. So the easiest way to do this with r's is to square both sides. So then I get r squared equals 9, because then I can change r squared into x squared plus y squared using those equations up there. And that's it. We have now changed it from an r equation to equation with x's and y's. And if you want to see that these are the same thing, we can look at Desmos. So here's Desmos. I have my x squared plus y squared equals 9. There's that circle. And if you look at r equals -3, it is the exact same circle. So they are the same graph. One is just using x's and y's, the other is using r's. And technically thetas, but there's no thetas in this one. Let's try another one. We have theta equals 4 pi thirds. Now, the only equation we have that uses theta is tangent of theta. So let's actually take the tangent of both sides of this equation. So then we have tangent of theta equals tangent of 4 pi thirds. Because I know that tangent of 4 pi thirds from the unit circle is √3. And now I can change tangent of theta to y over x using those equations we started with. If I multiply both sides by x, I get y equals √3x. And we can think about these ones logically. If I have tangent equals 4 pi thirds, or sorry, not tangent, theta equals 4 pi thirds, that's going to be a line like this, where this is my positive r values, this is my negative r values. And that line sure does look a lot like y equals square root of 3x, where the slope on this is square root of 3. One last problem. So let's come down here. R equals 1 minus cosine of theta. Let's start by squaring both sides. So then we can get our r squared. This is 1 minus cosine of theta times 1 minus cosine of theta. Now, one thing I would notice right away, I tried squaring this like we normally do, but if I FOIL this out, I'm going to get something grosser than what I started with. I don't have any equations that use cosine squared of theta. So maybe instead of squaring both sides, let's go back to the drawing board and let's times both sides by r. Because r times r still gives me the r squared I want, but when I distribute this in, I get r minus r cosine of theta, which I know that is going to turn into x, and this is going to turn into x squared plus y squared. So let's do this. I'm going to bring this over to the other side. So I get r squared plus r cosine of theta equals r. The r squared I'm going to turn into x squared plus y squared. The r cosine of theta I'm going to turn into x from my equations. And we're almost there. I just need to get rid of that last r. So instead of timesing everything by r again, because that just brings more r's into the equation, I'm trying to get rid of them, let's square it this time. So then I get x squared plus y squared plus x, everything squared, equals r squared. And then I can change that last r squared into x squared plus y squared. And now that equation only uses x's and y's. So I took it from something that only uses r's and thetas into something that only uses x's and y's. And once again, we can go to Desmos to show that these are the same thing. If I take my really complicated x and y equation, I get this cool looking graph. If I graph r equals 1 minus cosine of theta, I see that they are the same graph. So we have successfully changed it from an equation that uses r's and thetas to one that uses x's and y's. And that is all for 6.1. In the next lesson, we're going to dive deeper into graphing these really cool looking equations. I'll see you there.